This is the Geometry Honors Chapter 10 test review. We're going to begin with the first problem, which is a word problem. We need to read through and see what we're being asked to do. So when designing a building, you must be sure that the building can withstand hurricane force winds, which have a velocity of 74 miles per hour or more. Okay, so that's probably important right there. The formula F equals 0.004 AV squared, they gave me a formula that's probably really important too, gives the force F in pounds exerted by a wind blowing against a flat surface. A is the area of the surface in square feet, and V is the wind velocity in miles per hour. How much force is exerted by a wind blowing at 75 miles per hour against the side of a building shown? Okay, so they tell us that we need F is pounds, force in pounds, and A is the area, V is the wind velocity. So if they want me to find the force and they gave me my wind velocity, all I need to do is find my area. So really, this whole question is just asking me to find the area. And then I just have to plug into this formula they've given me. So to find my area of this, I have two different shapes. I have this triangle, and I have this rectangle. So I'm going to find the area of the triangle and the area of the rectangle, and I'm going to add them together. That's going to be my total area. So the area of my triangle is 1/2. Base is 21 feet. And my height is 6.2 feet. And then my rectangle here is base times height, which is 21 feet times 12.5 feet. So I need to take that and put that into my calculator. So I have 21 times 12.5 gives me 262.5. And then 0.5 times 21 times 6.2 is 65.1. So I'm going to add those two things together, and I get 327.6 feet squared is my area. But now the question doesn't ask for just the area. Okay, that's just what we had to find in order to get our answer. It asks how much force. So now I need to plug this into my formula. F equals 0.004. My area is 327.6, and my velocity, they told me, was 87 miles per hour. So 87. And let's multiply this together. Oh, and I almost lost, notice in the formula it says V squared. I almost lost that here, so I need to put that in. 87 squared times 327.6 times 0.004, enter. And I get 9,918.4. So when I look at my answer should be B, about 9,918 tons. In the second problem, all I have is a parallelogram. I'm looking for the area. So I know area of a parallelogram is base times height. So I just plug in those values. Now it's important to remember that your base and your height must be perpendicular. So this 29 here has nothing to do with the problem. All I need is the 33 and the 22 because those are the things that are perpendicular. So 33 times 22, I get 726, and don't forget your units, inches squared. Here I have a triangle, so area equals 1/2 base times height. 1/2, my base is 10, and my height is 6. That gives me 30 centimeters squared. Here I have another irregular shape similar to the first problem dealing with that house. So I have a rectangle and a triangle. I'm going to find the area of the rectangle first. So that's going to be base times height. which gives me 9 centimeters times 13 centimeters. So 9 times 13, I get 117 centimeters squared is that first area. But I also need to find the area of this triangle, which my base is right here, that's 11. But I have to figure out what this height is. So I have to do a little bit of math. If I know that this whole length here is 13 centimeters, and I know that this piece is 8, well then this piece must be 5. So I plug that in. Now I get, oh, and I have to multiply that by 0.5. I almost forgot my 1/2 base times height. So I get 27.5 centimeters squared is the area of my triangle. And now I have to add that with the area of my rectangle that I already found. So my area of this object is 144.5 centimeters squared. That is your final answer for this problem. Now this is that parallelogram problem where they don't want you to find the area, they actually want you to find h. And remember, I gave you an easy way to do this where you're setting your two areas equal to each other. First, identify your two right angles within the problem. Once you have those, you're going to find the two measurements that give you those right angles. So for example, this first one is created by 24 and 36. So I take 24 and multiply it by 36, because that is my formula for area of parallelogram, base times height. Now the other right angle I can see is created by h and 27. So I have 27 times h. That gives me 24 times 36 is 864 equals 27h. Divide by 27, divide by 27. Now my h is by itself, and I get h is equal to 32. And they don't give us any units in this, so I just leave 32. Find the area of an equilateral triangle with a side of 10. Okay, so first let's draw our equilateral triangle. And it tells me that there is a side measure of 10. Okay, so what I'm going to do is I'm going to take this triangle and I'm going to draw in the height, and then I'm going to try to calculate it. So if I have an equilateral triangle, I know that each of the angles is 60 degrees. So then these both up here are 30. Well, I can do some trigonometry now. If I'm trying to find my height, and if I'm looking at this angle here, for example, then I have the opposite side and the hypotenuse. So if I have the opposite and the hypotenuse, I need to use sine. Sine of 60 degrees equals opposite over hypotenuse. Because my variable is on the top, I multiply these two things together here, and I get that x is equal to 10 sine 60. And I plug this into my calculator. And remember, our calculators in class, we can plug it in exactly like that. Some of the other calculators are different, though, including the iPhone. So I have 10 sine 60 Oh, sorry, my calculator's in the wrong mode. There we go. Okay, so 60. Okay, I get x equals 8.6603. Remember, I told you, make sure you round within a problem. Don't round twice within a problem or 3 times within a problem, because then every time you round, your answer gets less and less accurate. So that could cause you issues on the test or on the end of course. So I'm going to write out quite a few decimal places here. Get x equals 8.6603. Now that I know that, I have my base, because that was my 10 here, and I have my height, so I can plug in area equals 1/2 base times height. So 1/2, my base is 10. My height we just calculated to be 8.6603. I'm going to take that times 10 times 0.5. So my area that I get is 43.3. And they don't give us units. So if you wanted to, you could write units squared. But because they don't give you units, it may just be 43.3 as an option. It may be 43.3 units squared as an option. All right, so now we've got a trapezoid. Our formula for the area of a trapezoid, is area equals 1/2 your height times base 1 plus your base 2. So I have 1/2. Remember, your height is always your perpendicular, so because they've given me this perpendicular, I plug in 5 there. My two bases are 9 and, they didn't give me my other base, so I'm going to have to calculate that. So they tell me that this piece is 8 centimeters. I know that this piece is going to be 9 centimeters because it's opposite of the 9 here in this rectangle. So I can write that in there at least, 9 centimeters. Now, it's very, very tempting to put that this piece is 8 centimeters as well, because you're like, oh, well, it's an isosceles trapezoid. Look at it. It looks perfect. Here's 8, so this has to be 8. Not true. This is very tricky. You have to be careful. If this triangle here has a 90-degree angle here, which it says it does, and a 45-degree angle here, which it says it does, then this also has to be 45, which makes this an isosceles triangle, even though it really doesn't look like it. If this is a 45-degree angle and this is a 45-degree angle, these two sides are congruent. So if this is 5, then this side also has to be 5, which is very counterintuitive. So be careful with that problem. Make sure you're paying attention to the detail. So my other base then is 9 plus 8 plus 5. 9 plus 8 plus 5. 9 plus 8 plus 5 is 22. Now I add that to 9, multiply times 5, and I cut it in half. And I get an area of 77.5 centimeters squared. Here I have another trapezoid. In this trapezoid, they've given me my height because it's this piece right here, this one leg of my trapezoid. They also give me my two bases, the 8 inches and the 12 inches, so I can plug into my formula. Area equals 1/2 height times base 1 plus base 2. And I get 1/2. My height was 7 and 8 plus 12. Okay, so let's plug that into our calculator. 8 plus 12 gives us 20. We're going to multiply that times 7 and then times 0.5. And I get the area equals 70 inches squared. All right, here we have another problem where we have to look at sine, cosine, and tangent, because I have my one base at the very bottom here, but I don't have my height and I don't have my other base. So I'm going to have to find both of those values. I can call my height x. Now, in order to find this other base at the top, what I have to do is I have to determine how big this piece is. I'm not sure how big this little piece is. I know the whole thing is 13. If I subtract this little piece, that's what gets me my upper base. So I'm going to call that little piece y. Okay, so x. If I'm dealing with x and I'm standing at the 60 degrees, that's my opposite side and my hypotenuse that I'm dealing with. And when I have opposite and hypotenuse, I know I have to use sine. So sine of 60 degrees equals opposite over hypotenuse. I'm going to multiply those two things together, which gives me x equals 6 sine 60. And I'm going to plug that in after we figure out what the formula for y is going to be as well. So y, if I'm standing at 60, y is my adjacent and my hypotenuse. So adjacent and hypotenuse, I'm using cosine. So cosine of 60 degrees equals adjacent over hypotenuse. And here again I have to multiply. So I get y equals 6 times cosine of 60. And I'm going to plug both of those into my calculator. Okay, so if I'm dealing with x, I have 60. Okay, I get 5.19615. That's my x. Okay, my y is going to be, oops, that's not right. No. My y is going to be 3. Okay, so that one's a nice round number. Okay, if y is 3, I'm going to write that in right here. Y is 3, which means that this piece up here must be 10. So I've now determined my upper base, which is a good thing. And I know that my x is that long decimal 5.19615. Okay, so I have my height, I have my two bases. Now it's time to plug into our formula. Area equals 1/2 height times base 1 plus base 2. When I plug in, I get 1/2 my height, 5.19615. And the sum of my bases, 10 plus 13. So my calculator, 10 plus 13 times 5.19615 times 0.5. I get that my area equals 59.7557, so 59.8, and my unit, feet squared. Okay, area of a kite. So area of a kite is diagonal 1, diagonal 2. Almost forgot my 1/2 in there. I'm going to just put the 1/2 at the end. So 1/2 diagonal 1, diagonal 2. So my diagonal 1 is 8 plus 16, which is 24. My diagonal 2 is 5 plus 5, which is 10. So I get 1/2 times 24 times 10, which equals 120 feet squared. All right, here we've got a rhombus, but it's the same formula. We're still going to use area equals 1/2 diagonal 1, diagonal 2. So my first diagonal is 12, and my second diagonal is 12, which makes sense because in a rhombus, my diagonals are congruent. So I have 1/2 12 times 12, which is 1/2 of 144. So 144 divided by 2, I get 72. My units, meters squared. Okay, here I have a regular hexagon and I'm trying to find each of the numbered angles. So to begin with, for angle 1, this is a central angle. To find a central angle, I'm going to take 360 divided by the number of sides. So which in this case is 360 divided by 6. And I get angle 1 equals 60 degrees. Okay, off to a good start. Now angle 2, if I look at angle 2 here, I see that that is half of a central angle. So I'm just going to take angle 1, which equals 60, I'm going to cut it in half. So angle 2 equals 30 degrees. And now angle 3, that is half of an interior angle. So if you look at this, I have an interior angle here, which I can find using the formula n minus 2 times 180 divided by 2. So I'm going to plug in and find that value. But then at the end I'm going to cut it in half because I only want half of it. So I have 6 minus 2 times 180 divided by 2. When I plug that into my calculator, I get 300, no, that's not right. I got 360 with that. Oh, I'm sorry. Why did I divide it by 2? Ay. This is the mistake that you guys will probably make on the test. This is what you did in class. I'm losing my mind. N minus 2 divided by 180 divided by n. This should not be 2 here. This should be n. So this should not be 2. This should be 6. Be very, very careful. See how easy it is to do that? Oh my goodness. Okay, so I have 4 times 180 equals divided by 6. So each of my interior angles are going to be 120. But we don't want that whole thing. We only want half of that. So now this is where I divide by 2. And I get an answer of angle 3 equals 60 degrees. So be very careful. Use your brain. Think about what these possible answers could be. Does it make sense that angle 3 equals 60 degrees? Yes, that definitely looks like 60 degrees. Had I gone through and done it the other way, I would have gotten an answer of 180. And clearly angle 3 is not 180. So make sure you're checking your work as you're going. All right, this next example, find the area of a regular hexagon with, a pothum, 14.7 centimeters, and side 17 centimeters long. Round your answer to the nearest tenth. Okay, so if you remember, we have the formula, area equals 1/2 AP. So I can plug in my apothum right out the bat. They tell me 14.7. But my perimeter, they only give me my side. I need to calculate my perimeter. So if my side is 17, and it's a hexagon, I know a hexagon is 6 sides. So I'm going to take my 17 times 6. 17 times 6 gives me 102. That is my perimeter. That's what I plug into this formula. So 102 times 14.7 divided by 2. I get that this has an area of 749.7 centimeters squared. So in order to do problems like these, you have to know how many sides does a hexagon have, how many sides does a nonagon have, how many sides does a dodecagon have. Remember, dodecagon's 12, not 20. So you have to make sure you know those for tomorrow's test. Okay, here you're planning to use a ceramic tile design in your new bathroom. The tiles are blue and white equilateral triangles. You decide to arrange the blue tiles in hexagonal shapes as shown. If the side of each tile measures 7 centimeters, what will be the exact area of each hexagonal shape? All right, so basically here, they've given you this hexagon and they've given you a side length. In order to use the formula, area equals 1/2 AP, we need to find the apothum here. So I'm going to draw in my apothum, and I'm going to call it X because that's what we're looking for. Now, it told me that these are equilateral triangle tiles, which are arranged in a hexagon. So I know that this angle down here is 60 degrees because that's an equilateral triangle. Okay, so I'm going to set up some trigonometry. If I'm standing at the 60, I know that my opposite side is X. So I would definitely want to use my opposite. I don't know anything about my hypotenuse, but I do know that my adjacent is this 7, but cut in half because I only want this little piece of it. So my adjacent is 3.5, and we said our opposite was x. So here I'm going to have to use tangent because I have TOA. So tangent of 60 degrees equals opposite over adjacent. I'm going to take these, I'm going to multiply opposite over adjacent. So let's plug this into our calculator. I have x equals 3.5 tangent 60. Sorry, I'm using the calculator on my phone, which is a lot smaller. Okay, so I get x equals 6.06. Okay, so now I have my apothem. My perimeter they haven't given me, but since they gave me a side, I can calculate perimeter. Perimeter is going to be 7 times 6 sides, which is 42. So now let's plug in. We've got area equals 1/2. Our apothem is 6.06. And see, I didn't even follow my own rule. 218. 6,218. That was my answer, not rounding to just 2 decimal places. I multiply that times 42. Times 42 equals, and I get my area is 127.3. Okay, now, units, centimeters squared. Now, I do want to clarify something in the question. It does say what will be the exact area of each hexagonal shape. This is important. What we just found is not an exact area. It is an approximation. It's pretty close, but it's not exact. What they mean by exact is including like radicals. So you're not rounding anything. You have, for instance, radical 3 in your answer. Now, if this is on a multiple choice test and all of your answers are including radicals and things like that, not decimals, all you have to do is take your decimal answer that you have just found, and you are going to try to figure out which of those multiple choice answers will get you that decimal. You can do that by just plugging those answers into your calculator and finding the decimal representation for the radical 3 in the answer that they have found. Okay, find the area of an equilateral triangle with radius 8 radical 3. So I'm going to draw my equilateral triangle. I have a radius of 8 radical 3. So remember, your radius goes from your center to an angle or a vertex. So that value is 8 radical 3. All right, so again here, they've given me my radius, but I don't have my apothem, which I need, and I don't have my perimeter. So I'm also going to need this side right here. So I'm going to call these x and y, and I have to look at some trigonometry again to calculate these values. Okay, so if I have a triangle, then I know that each angle is 60, meaning this angle here is a 30-degree angle. That says 30. Okay, so if that's a 30-degree angle, now I'm going to set up my trigonometry. So if I'm standing there to find x, I have my opposite over my hypotenuse. So opposite over hypotenuse, that gives me sine. So sine of 30 degrees equals opposite over hypotenuse. Okay, and then for y, I have my adjacent and my hypotenuse. So adjacent and hypotenuse, that's cosine. Cosine of 30 equals adjacent over hypotenuse. So when I put these into my calculator, we need to do 8 radical 3 sine 30 and 8 radical 3 cosine 30. Now here's the thing though, 8 radical 3, I need to get a decimal representation of. In your calculators that we use in class, I think you can probably just enter that straight in and it'll give you your answer back in radical form. But for right now, I am going to Well, actually, I can put it into my iPhone too. If you're using an iPhone, you can do that as well. So let's see, if we're using the iPhone. I'm going to plug that into my calculator. Sine of 30 times 8. And I'm going to break it up. I'm going to say times 8 times parentheses radical 3. And I get that x equals 6.9282. Now my y I get 12. Okay, so now if y is 12, then I know that my whole side here is 24, and I have 3 sides, so 24 times 3 will get me a perimeter of 72. And I know that my apothem is 6.9282, so I'm going to plug this in. Area equals 1/2 AP. 1/2 apothem is 6.9282. Perimeter is 72. And I just put that into my calculator. And the first time I did that, I got 249.4. I'm going to go back and check that again, though, because I may have hit the wrong button. 72 times 6.9282 times... Yep, okay, that's good. So 249.4. Now again, it says leave your answer in simplest radical form. If you do this in our calculators at school, you may be able to do that without dealing with this decimal. It may actually give you radical form in that calculator. Remember, if you're using math print. But if you're not, here's your answer, meters squared. You can always go back and check your multiple choice options, A, B, C, and D, and see which one will provide you with that decimal. All right, so this problem, we have a regular hexagon. So I'm going to draw my hexagon. And I have a perimeter of 50. If I have a perimeter of 50, what that means is each side, if I divide that by 6, is 8.3 repeating. That's each side. I have to find my apothem. So let's draw this radius in. We now have a triangle. I know that this is a 60-degree angle, and I'm going to set up some trigonometry. So if that whole side is 8.3, if I cut that in half, each little piece here is 4.1666. I'm looking for x. So if I'm standing at that 60, I have my opposite and I have my adjacent. So I'm using tangent. So tangent of 60 degrees equals opposite over adjacent. I'm going to multiply those two things. So I get x equals 4.16666 times tangent of 60. So let's plug that into our calculators. Tangent of 60, but I need to take that times 4.16666. I get an answer of x equals 7.2169. So now I have my apothem and I have my perimeter. They gave me my perimeter right from the get-go. So I have 1/2 A is 7.2169 times the 50 they gave us as our perimeter. So let's see what that gets us. I get my area is 180.4 meters squared. And again, it said in the directions, leave your answer in simplest radical form, but you can go ahead and just match up your decimal to what their multiple choice answers are. All right, here we're talking about ratios now. They say these figures are similar. Give the ratio of the perimeters and the ratio of their areas. The first figure to the second. First, first figure to the second figure. So I want first figure is 18 over second figure is 16. I'm going to reduce that. Divide by 2, I get 9 over 8. So this is my perimeter ratio. But remember, to get area, this is what you guys need to make sure you remember. For the area ratio, you need to square. You need to square that value. So you're going to take the 9 over 8, you're going to square it, which gets you 81 over 64. And this is your area ratio. All right, find the ratio of the perimeter of the larger rectangle to the perimeter of the smaller rectangle. Okay, so all I have to do to find the ratio of the perimeter is just look at the similarity ratio. So I'm going to focus in on either my height or my base. It doesn't matter which one. So I'm going to look at my 9 and my 12. And it says, of the larger rectangle to the smaller rectangle. So what we want to write is large over small. So my large is 12 feet over my small is 9 feet. I can reduce that by dividing by 3, and I get 4 over 3. The trapezoids are similar. The area of the smaller trapezoid is 131 meters squared. Find the area of the larger trapezoid to the nearest whole number. So the first thing I have to do is recognize I'm looking for some areas. So in order to get this other area, I need my area ratio. That is what I need. So I'm going to look at these, and I'm just going to identify my area ratio first. I have, let's do small over large, which gives me 12 over 64. And I can simplify that because I can divide both of those. I think 64 is divisible by 4. So let's see, 12 divided by 4 is 3. 64 divided by 4 is 16. That is as simplified as it gets. So now that's my perimeter ratio. But I don't want my perimeter ratio, I want my area ratio. So I need to take that 3 over 16 and I have to square it, which gives me 9 over, oh boy, 16 squared is 256. Wow. Okay, so my area ratio is 9 over 256. So now what I'm going to do, and remember, sorry, that's small over large. That's important to keep track of the whole time. So it's 9 over 256. They told me the area of my smaller trapezoid, so small is 131, and I'm trying to find the area of my larger. Now what I have here is a proportion, so I just cross multiply. I get 9x equals, oh boy, 256 times 131 gives me 33,536. I'm going to divide that, sorry, that's a 9. Divide it by 9 to get x by itself. And I get 3,726. And it says round to the nearest whole number. So that is going to be your answer, meters squared. Hiram raises earthworms in a square of compost 4 foot by 4 foot. 4 foot by 4 foot. He can have 1,000 earthworms. How many earthworms can he have if his square of compost has side length that is 5 times longer? Okay, so what that's saying is my big over small, the ratio of the perimeter, oh, side length, okay. So let's draw another square here real quick. Side length is 5 times longer. So if this side length is 4, then 5 times longer than that is 20 feet, which means my big is 20, my small is 4. My scale factor, which is my similarity ratio, which is the same as my perimeter ratio, is 5/1. So that's my perimeter ratio. But the amount of earthworms inside is going to have to do with the amount of area that they have in dirt to like live in. So I need to take that and I need to square that 5/1 to get 25/1 being my area ratio. Now that I have that, if he can have 1,000 earthworms in his small, how many can he have in his large? So I'm going to cross multiply just like we did in the last one. I'm going to take that 25 times 1,000, and I get that he could have 25,000 earthworms in that larger thing of dirt. All right, two trapezoids have areas of 432 centimeters squared and 48 centimeters squared. Find their ratio of similarity. So I'm going backwards. I want 432 over 48. 432, I wonder if I can simplify that. 432, because that's not a perfect square. And remember, to go backwards, we have to take the perfect square of things. So let's try, like, maybe it is a perfect square. 432. Can I take the square root of it? No, that doesn't work. Okay, so 432 divided by 2. If I divide that by 2, I get 216 over 24. Can I take the square root of 216? 216, square root. No, that doesn't work either. I can divide those by 2 again. Let's see what we get. 216 divided by 2, we get 108 and 12. Can't take the square root of either of those. So divide by 2 again. I get 54 over 6. Can't take the square root of those. 54 divided by 2. Okay, reduce again. I get 27 over 3. Oh, now I divide by 3. I get 9 over 1. So all of that simplification, I get all the way down to 9 over 1. That's what I'm trying to take the square root of, and that's simple. I get 3 over 1. So to recap, what we did is we took our two areas and we set them up in a ratio, 432 to 48. And then I just started simplifying to see if I could find some perfect squares. I divide by 2, divide by 2, divide by 2, divide by 2. Once I divided down here to 3, I got 9 over 1. So that was my simplified fraction. Then, as I had the simplified fraction where I could take the square rooted both, I got 3 over 1. So 3 over 1 is your answer. That's their similarity ratio. Find the area of a regular polygon. Give the answer to nearest tenth. Okay, so I have a pentagon. Let's draw a pentagon. My side is 8 feet. Okay, here we go. We're drawing in our apothem. We need to draw in our radius, so we have a triangle. I need to figure out what one of those angles is. So I am going to find my central angle. I think that one's easier to find. So I take 360 divided by 5, but I need to cut that in half. So I get 36. That angle right there is 36 degrees. I need to find my apothem. I know that this piece here is 4 feet because it's half of this 8 that they gave me. So I have, if I'm standing at 36, opposite is 4, and my adjacent is what I'm trying to find. That's x. So I'm going to use tangent of 36 degrees equals opposite over adjacent. Now, when your x is on the bottom like this, you need to switch these two things. So you have x equals 4 divided by tangent of 36. Okay, so calculator. 4 divided by tangent of 36, I get x equals 5.5055. Remember, I'm not going to round. I'm going to carry out some decimal places so that my answer is more accurate. Okay, so now I know my apothem. My perimeter is going to be the 8 feet times 5 sides. So 8 times 5 gets me 40. 1/2, my perimeter, my apothem is 5.5055, and my perimeter we just calculated to be 40. 5.5055. I plug that all into my calculator, and I get my area equals 110, answer to nearest tenth, 0.1 feet squared. All right, the Ruffs are planning to buy an above-ground swimming pool shaped as a regular octagon. Oh my goodness. Could you imagine having an octagonal-shaped swimming pool? It's craziness. Okay, so there's my octagon swimming pool. The radius of the octagon is 9 feet. My radius is 9 feet. To the nearest tenth, find the area of the surface of the water in the pool. So I'm looking for the area of this thing. I need to draw in my apothem. I need to find that. That's my x. But I also need to find this little piece here so I can find my perimeter. So we call that y. So again, we're looking at trigonometry, but I need an angle. My easiest angle to find is this one up here. So I take 360, and I divide it by the number of sides, which is 8. But then I cut that in half. So this angle up here is 22.5 degrees. Sorry, that's really hard to read. Let me try that again. 22.5 degrees. There it is. Okay, here we go. We're going with our trigonometry again. If I'm standing at 25, I have my opposite is y, and my hypotenuse is 9. So opposite and hypotenuse, that's sine. So sine of 22.5 equals opposite over hypotenuse. That means when I plug that into my calculator, I'm going to need 9 times the sine of 22.5. If I'm looking for x, that is my adjacent and my hypotenuse. So adjacent and hypotenuse means I'm using cosine. So cosine of 22.5 is x over 9, which means when I plug it into my calculator, I need 9 times the cosine of 22.5. So let's plug both of these into our calculator. For for y, I get 3.4415. And for x, I get 8.3149. So those are my x and my y values. Now my x is my apothem, so that I'm done. That's going to go into my formula. So let's plug that in. 1/2 AP, 1/2 8.3149. But my perimeter, right now y is just this little piece here. So I need to take that 3.44415. I need to multiply that by 2. That gives me my whole side length being 6.8883. But I have 8 sides, so I multiply that by 8. And I get my perimeter is 55.1064 times 8.3149 times 0.5. So I get my area is 229.1 feet squared. Okay, let's read through this problem. 2 triangles each have adjacent side lengths 120 feet and 180 feet. The first triangle has an angle between the 2 sides of 40 degrees. while the second triangle has an angle between the two sides of 60 degrees. What is the approximate difference between the two areas of the two triangles? Okay, so if they tell me my two adjacent side lengths, they're not the same. So I know I'm not dealing with an equilateral triangle, which gets me away from that whole 1/2 AP thing. But I know that I have two sides of a triangle, two sides of another triangle. Here I have 120 and 180. Oh, but they're the same. Both of the triangles have those same measurements there. Two triangles each have adjacent side lengths of 120 and 180. So there's my two triangles. I don't know what the other side looks like, but it does say the first triangle has an angle between the two sides of 40 degrees, and the second triangle has an angle of 60 degrees. So what's the formula that we know having to do with my angle here? We learned something. It was the area of a triangle equals 1/2 BC sine A. So I do have two sides, and I do have the angle that's in between them, which we call the included angle. So I can find the area of each of these two triangles. I'll just close them out. I don't know exactly what they're going to look like. But I have 1/2, see, I'll use another color here, 1/2 120 times 180 times sine of 40. So let's plug that in and see what we get. We have sine of 40 times 120 times 180 times 0.5. This first triangle, I get, wow, 6,942.10618. And that's going to be feet squared. Let's look at what we would get for the other triangle. There I would get 1/2 times 120 times 180 times sine of 60. So let's plug that into our calculator. There I get 9,353.07436. Now the question says, what is the approximate difference between the areas of the two triangles? So I'm going to take this area we just calculated, I'm going to subtract the 6,942.10618. And my answer is 2,410.96818. So I'm going to say the approximate difference is 2,400, and, oh geez, don't do that. Oh no! All right. Sorry all the work went away. You can go back and you can, oh, beautiful, perfect. Okay, sorry about that. So my answer is not 2,410, it's 2,411 feet squared. That's the approximate difference between those two areas. All right, in our last problem, all we have to do is find the area of this triangle. I'm using that same formula, BC sine A. Remember, this one's not on your reference sheet, so we need to make sure that we remember this. 1/2 times my first side times my second side times the sine of my angle. Plug that all into the calculator. And we get 41.8, because it says nearest tenth. My units, centimeters squared. All right, make sure you study up, and I will see you in class.